Hawker Siddeley Harrier GR1 officially entered operational service with the Royal Air Force on the 1st of April 1969 with No. 1 Fighter Squadron at RAF Wittering. The Harrier GR1A was a slightly later uprated variant that first flew on the 11th of June 1971, featuring a more powerful Rolls-Royce Pegasus Mark 102 engine to provide extra vertical thrust. The heart of the aircraft's navigation was the Ferranti FE541 Inertial Navigation Attack System. Originally developed for the cancelled supersonic BAC P1154 project, it was adapted directly into the first generation Harrier. In the absence of modern satellite navigation systems that we have nowadays, the system relied on a nose-mounted inertial platform bolted tightly to the cockpit's pressure bulkhead. It utilised highly sensitive internal gyroscopes and accelerometers to track the aircraft's exact movement in 3 dimensions. Because it calculated position entirely by dead reckoning, measuring acceleration over time, it could not be jammed by enemy forces. The inertial platform fed data directly into a central present position analog computer, which translated physics data into navigation coordinates and linked it directly to the pilot's head-up display. To make the inertial data immediately useful to a pilot flying at 500 knots just above the treetops, Ferranti created a revolutionary mechanical head-down moving map display located in the centre console. Instead of a digital screen, the device utilised actual 35mm photographic film cassettes, standard 1 to 500,000 scale topographical military maps were photographed and loaded into the internal motorised rollers. So instead of a digital computer rendering a graphic, the Ferranti moving map was essentially a highly ruggedized miniature 35mm film projector built directly into the cockpit console. Inside the unit, a powerful internal halogen lamp shone light through the film. A series of lenses and mirrors back projected the map image onto a 6-inch circular translucent glass screen facing the pilot. The display was driven by the Harrier's inertial navigation computer. As the aircraft flew, microscopic electric servo motors and gearheads physically rolled the film strip up and down for north-south movement and slid the optical carriage left and right for east-west movement. The aircraft's current position was represented by a fixed crosshair or airplane silhouette etched into the centre of the glass screen. The physical map moved beneath it in real time. Pilots could manually switch between map scales, a wide view for transit and a tight detailed view for target approach. The mechanism physically swapped out internal magnification lenses to resize the film projection cleanly. Navigational data from the present position computer, such as destination waypoints, drift angles and look-ahead lines, were optically superimposed over the map image using tiny internal slit mechanisms. The map cassette could hold enough film to cover a vast operating theatre, roughly 800 miles north to south and 900 miles east to west. If a pilot flew off the edge of the active film section, the mechanism would automatically slew and roll to the next section. The system relied on hundreds of tiny gears, rubber bands and rollers. With high G manoeuvres, heavy vibrations from the Harrier's vertical thrust, and cockpit heat meant the mechanism required frequent maintenance to prevent the film from jamming or tearing. During regular maintenance, these units were removed from the airframe and returned to Ferranti for testing, adjustment and calibration on this test bench, before being returned to their aircraft. We all take satellite navigation and digital screens for granted nowadays, but in an era where none of that existed, The men and women with genius minds and exceptional electrical, mechanical knowledge and engineering skills created this masterpiece. And over 50 years later, this unit finds itself reunited with the bench that it used to be calibrated on in Ferrante's. That bench is now my workshop bench.